In this section, we'll be graphing a system of linear inequalities. So let's take a look at the first example. Let's say we have 4x plus 6y is less than or equal to 36, and we have 2x minus 8y is less than or equal to 24. So this is our system of two linear inequalities. Now, in the section on linear inequalities in two variables that we did earlier, we learned how to graph linear inequalities. We know that for a less than or a greater than sign, we put what's called a dotted line when we constructed the line. That means we don't include any points on that line. And we saw that when we have a less than or equal to or a greater than or equal to, we just drew a solid line indicating that we included all the points on that line. Now, we also saw that when we have a greater than or equal to sign, that we shaded above the line. When we had a less than or equal to sign, we shaded below the line. So these are things that we learned when we were looking at linear inequalities and graphing them in two variables. Now we're going to learn how to graph a system of linear inequalities on the same coordinate plane. We do this by graphing the inequalities separately on the graph, which is what we learned earlier, and the solution for the system is the common shaded region between all the inequalities in the system. So we're just going to start out with systems of two linear inequalities, and then we'll increase from there. So to solve a system of linear inequalities, we need to graph them and find the intersecting region of the solution. So we're going to rewrite each one of these equations and put it in slope-intercept form, simply because slope-intercept form makes graphing and shading much easier, as we saw in the previous section. So let's go ahead and rewrite these. We can subtract 4x from both sides in the first one, which gives us 6y is less than or equal to minus 4x plus 36. And we can go ahead and divide everything through by 6, which isolates our y. Putting it in slope-intercept form is the same thing as solving for y. So we have a minus 2/3 x and plus 6 right here. So this is our slope-intercept form of this linear inequality. Let's go ahead and do the other one as well. We can subtract both sides by 2x. So we have minus 8y is less than or equal to minus 2x plus 24. Okay, so now we can just simply divide both sides, everything on both sides, by minus 8. These two terms will cancel. These two negatives will cancel. So we have y on the left side. And recall, whenever we multiply or divide by a negative number, we need to flip the sign. So this less than or equal to becomes a greater than or equal to. Very important, because we'll actually get the wrong region, the wrong intersecting solution if we don't flip the sign. So 2/8 becomes 1/4 times x minus 24 over negative 8 is a negative 3. So this is the slope-intercept form of our two linear inequalities. So let's go ahead and graph these. So here is the y-axis, this is the x-axis, this is the positive direction for y, the positive direction for x. Let's go ahead and just make some dashes here. I believe most of this is the points are going to be in the positive direction. Okay, so let's go ahead and plot this thing. A very quick way when we have it in slope-intercept form is use the y-intercept as one point, and we'll just use the slope to graph a second point, and then we can connect the lines, or connect the dots with a line. So the y-intercept is where x is equal to 0, so if we plugged in 0 right here, we'd get y is equal to 6. So this line crosses the y-axis at y equals 6. So 1, 2, 3, 4, 5, 6, right here. We know several ways to find some points for a line or an equation or an inequality. So we're just actually using a very quick one so we don't waste a lot of time. All right, so now that we have a point on this line, we can go ahead and use this slope to find the next point. So we have a rise of minus 2 and a run of positive 3. So we go down 1, 2, and to the right, 1, 2, 3. So we have another point over here. And all we have to do is simply connect these two dots with a line. And it looks something like that. They both go in the positive and negative direction infinitely, and are made with a solid line because we have a less than or equal to sign. So we have a solid line containing all the points on this line for our interval, our solution. So let's find the second one. Before we actually shade this, We only want the common shaded region as our solution interval. So let's see what sections overlap. So if we plugged in 0 for x here, we'd have y equals a minus 3. So this line is going to cross the y-axis at minus 3. And we can use a slope to find another point. So we go up 1 and to the right 4. So up 1, then 1, 2, 3, 4. This is the second point. Let's go ahead and connect these two dots, these 2 points with a line. And you can actually see approximately where they intersect. But since we're talking about inequalities, we're no longer looking for a point that they're intersecting. We're looking for the shaded region. So the shaded region here, if we pick let's pick this color. Okay, so we're looking for everything that's beneath or below this line and above this line. All right, so this is line 1, this is line 2, this is the red line, this is the green line. So we want all the shaded region below the red line and above the green line. So our interval, our solution interval, is going to be all these values in here, or essentially between the 2 lines. All right, and that's all there is to it. This is graphing a system of linear inequalities, and this is 2 linear inequalities that we're working with in this first example. So we don't want anything on the other side of this line. This is actually the solution for this system of linear inequalities. It's what's below this line because it's less than or equal to, and it's above this line because it's greater than or equal to. All right, this is called an unbounded solution because it continues forever in at least one direction. All right, so let's go ahead and look at another one. We'll look at plenty of examples of these before we move on. So next we have the system of inequalities. Minus 2x plus y is greater than or equal to 3. And we have 2x plus 2y is less than or equal to 8. So this is our system of linear inequalities. So let's go ahead and solve for y so we can get them both in slope-intercept form. So if we add 2x to both sides here, we'll get a y is greater than or equal to 2x plus 3. And if we subtract both sides by 2x here, we'll get a 2y is less than or equal to minus 2x plus 8. Let's go ahead and divide everything through by a positive 2. That'll get our variable y by itself is less than or equal to a minus x. Minus 2 over 2 is just a minus 1, plus 8 over 2, which is 4. Okay, so we have both of our lines are linear inequalities in slope-intercept form, so let's go ahead and, let's go ahead and graph this thing. Here's our y-axis, here's our x-axis. This is the positive y direction, this is the positive x direction. We should be very familiar with graphing by now, even linear inequalities, because we've done a whole section on this. Not a whole lot to it. All right, so let's go ahead and pick out a few points. So for our first line, line 1, we're going to look at, we're going to plug in x equals 0. When we do so, y equals positive 3, so the line's going to cross the y-axis right here. And we can use the slope of 2 over 1 to find another point. So we go up 2 and over 1. There's another point, and we're going to go ahead and connect these with a line. That is our linear inequality. Y is greater than or equal to 2x plus 1. And again, it's a solid line, including all the points on this line in our interval, because we have an equal to sign. All right, let's go ahead and find the line for the second equation. If we plug in 0 for x, we get y equals plus 4, so this line crosses the y-axis right here. We have a slope of minus 1, so it's going to drop down 1 and go over 1. So we have another point right there. Let's go ahead and connect these two. There we go. These two continue infinitely. It's a solid line because it's less than or equal to, so we're including all the points on this line. And the region that we want is the area that's greater than this line 1, so on this side, but less than this line. So we're looking at this region right here. This is our solution region, our solution interval. It's less than this purple line and greater than this red line. So we're only interested in values in this region right here. All right, so not a whole lot to graphing these, and we'll look at a few more in the next section. So I'll see you soon.